Good evening, everyone. My name is Vidyanand and I am from ECEC section. My roll number is 20BQ1A04G4. Today I am going to say about the differences between the galvanic cell and the concentration cell.
Firstly, coming to the definition of electrode. If any metal or non-metal which is in contact with its metal ion solution, then it has the tendency to lose or gain electrons. Then it is said to be an electrode, and the potential of that electrode is known as electrode potential. If any metal or non-metal has the tendency to lose electrons, then it is termed as single electrode potential for oxidation. This metal is to be well known as anode. If the metal or non-metal has tendency to gain electrons, then it is termed as single electrode potential for reduction. The metal is well known as cathode. Coming to the definition of oxidation. The ability of an element to lose electrons is known as oxidation. Coming to the definition of reduction. The ability of an element to gain electrons is called as reduction. Now coming to the concept of electrochemical cell or galvanic cell. An electrochemical cell is a device that produces current from energy released by spontaneous redox reaction. The electrochemical cell consists of two electrodes, which is known as anode and cathode, and two electrolyte solutions, and these two electrolyte solutions are connected by using salt bridge. This salt bridge mainly maintains the electrical neutrality between these two electrolyte solutions, and it also connects these two electrolytic solutions. In this galvanic cell or electrochemical cell, anodic oxidation takes place at anodic half cell and reduction takes place at cathodic half cell. On the basis of surface area of the metal, we decide that whether a metal acts as a cathode or anode. If a metal consists of less surface area, it consists of more charge density to release, so it acts as anode, and whereas the metal which is having more surface area will act as cathode. Coming to galvanic cell, here we are considering the cathode as copper rod which is immersed in copper sulfate solution, and anode as zinc rod which is immersed in zinc sulfate solution. At anode, we know that oxidation is going to take place. Writing the half cell reaction, we get zinc is oxidized to Zn plus 2. In the same way, at anode, writing the reduction half cell reaction, the copper is reduced to copper. Finally, the net reaction will be Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. EMF is 1.1 volt. Salt bridge mainly maintains the electrical neutrality between these two electrolytic solutions. Now coming to the concept of concentrating cell. A concentration cell is a kind of electrochemical cell in which electricity is produced by the transfer of matter from a system of higher concentration to system of lower concentration. Based on the concentration difference, they are classified into two types. One is electrode concentration cell and second one is electrolytic concentration cell. Firstly, knowing the definition of electrode concentration cell. A galvanic cell in which electrodes of same concentration or come in contact with two electrolytes of same concentration. Here only the electrode concentration will be varied, but whereas the electrolyte concentration will be kept same. Now let us consider an example. Here we take the electrolytic solution ZnSO4 with same concentration of 1 molar, but whereas the electrode concentration are different. At anode we consider zinc of concentration 1 molar, but whereas cathode we consider concentration of 0.1 molar. By calculating the equilibrium molar concentration, we get 0.55 molar. At anode, the zinc loses and reaches this equilibrium molar concentration, but whereas in cathode, the zinc gains and reaches this equilibrium concentration. Writing the half cell reactions at anode, zinc gives rise to Zn plus 2 plus 2 electrons. Here oxidation takes place. At cathode, the reaction will be like this. Zn plus 2 electrons gives rise to Zn. If we observe the net reaction, here only the transfer of mass takes place, which leads to development of electricity. Secondly, coming to electrolyte concentration cell, a galvanic cell in which two electrodes of same concentrations are come in contact with two electrolytes of same kind of different concentration. Here if we observe, the two electrodes are maintaining same concentration, but whereas the electrolytes are maintained in different concentration. Here the ZnSO4 of at anode electrolyte is maintained at 0.1 molar and cathode is maintained at 1 molar. The equilibrium concentration will be 0.55 molar. Here anode oxidation takes place and the zinc will reaches the equilibrium concentration, and the cathode also reduction takes place and the zinc will reaches the equilibrium concentration. Finally, looking the differences between the galvanic and concentration cell. Galvanic cell is a type of electrochemical cell that uses spontaneous redox reaction to generate electrical energy. Coming to concentration cell is a type of galvanic cell in which two cells are in similar composition. Electrodes in galvanic cell, electrodes can be made of either the same substance or different substance. Whereas coming to concentration cell, electrons of the same substance with either the same concentration or different concentrations. Coming to galvanic cell, electrolyte can be same electrolyte or different electrolytes in two half cells. But whereas in the concentration cell, the same electrolyte with either the same concentration or different concentration. Here we observe in the galvanic cell, E0 cell concentration will never be equal to 0, but whereas in concentration cell, it always equals to 0.
Thank you one and all.